Okay, so welcome to OCE Technology. This is a short video to demonstrate what you get with the E698 development kit. As you can see here, we've got the board with E698PM mounted on it and all the various interfaces. You will also get a power supply with the relevant regional connectors for your part of the world. You will get a serial cable to connect from the DSU or the serial port, the debug serial port, to your PC from where you will run daemon. You will get a Ethernet cable if you're connecting via the Ethernet. You will get a license dongle with a 1-year license for daemon 2. And you will get the software and documentation on a USB stick. Okay, so we are going to connect up the E698PM to a laptop running daemon and the IDE system. So we plug in the power to the AC power there. In this case, it's in Ireland, it's 240 volts AC. Connect the board to the DC connection and plug in our serial connector into the DSU port, which is this one here, DSU serial port. So you will need a laptop with a serial port. As many of the laptops don't have a serial port these days, you may be using, like me, a USB to serial converter. So we plug the USB into the USB port and the other end of the serial port into the USB serial converter. Okay, we're ready to go now. We can power up the board. The usual power up state is green LEDs. And this particular kit here is a V1 kit, but the procedure for the V2 kit is just the same. The board layout is slightly different. Okay, in this section we'll go through the installation of daemon onto your PC or laptop. So you need to insert the white OCE branded flash drive into a USB port on your laptop. When you've done that, if you go to the open up the flash drive, which should be called OCE, go to the IDE folder, then select the daemon folder. So in the daemon folder there's a number of files. The first file here is a Linux install file, then there's a Windows install file called daemon-version number-setup.exe. The user guide is here, a getting started document, and get it under Linux and under Windows, and some release notes. So let's run the setup file. When you run it, your user account control will prompt you if you want to proceed with the installation. You say yes to that. Okay, now there's a welcome message from the daemon installation program. Next, it asks us if we want to, if we will accept the license agreement. So the license agreement is displayed there. Click on I accept the license terms, click next. The default installation folder is now displayed. You can change that, but we're going to accept the default. Click next. It's now ready to start the installation, so let's click next. So it goes ahead and installs the daemon file. Daemon is a Java program, so it installs the Java files necessary to run daemon. Okay, it's finished the installation now. allows you to view the README file, launch daemon, create a desktop shortcut, or create a quick launch shortcut. So actually let's let it run all these. So displays a daemon README file, which we can close. It's created a desktop shortcut, as you can see on the desktop here. Daemon itself is running, but it is saying failed to find the license key. Insert a valid license key or close the console. Okay, so let's shut down daemon. The next step of the installation process is to install the license software, which is in this case in the eval license in the daemon folder. The program you need to run is called haspdinst.exe. This program has to be run from the command line because you need to pass it an install option. So we need to open a command line window. We need to open that in administrator mode. So if you right click on the command prompt option in your menu, select run as administrator. Now we have the command line window open, and so we need to switch to the folder that contains it's the E drive. It's the USB folder, and we need to change to the directory that contains daemon. So IDE daemon2, do a directory there, and then change to the eval license folder. Okay, so now we want to run the hasp dinst. So let's run that, and we need to give it the -I switch to direct it to do an installation. So when we do that, a small window should appear, Sentinel runtime environment, and please wait while it does the installation. Okay, in this case my virus checker has suspected suspicious activity, so I'm going to direct the firewall to allow it to proceed. Okay, so the Sentinel runtime environment is now installed. We can click OK. We can shut the command line window. Okay, so now if we run daemon from the icon on your desktop, this time we can see here that when daemon has started, if we look at the keys, it's found license information. In this case it's a software key, and it's a trial license with a start date of the 7th of February and an end date of the 9th of March. So this is the standard 30-day evaluation license. Okay, I'm going to stop daemon now. In the development kit you will also have received a black license key. You insert that into a USB port on your laptop, and then if you run daemon again, we will find that this time in the console messages when daemon starts up, in the license key information, it has found a hardware key, serial number of the hardware key, and the expiration date, which should be about a year after you purchased the equipment. There's a 1-year license with a development kit, which can be renewed at the end of the year. Okay, so daemon is now installed and we are ready to connect to a target. Okay, so now we're going to install the Orion 6 IDE. So first we need to go to the USB flash drive where the installation software is located in the Orion 6 IDE folder, and then we can double click on the installation program Orion 6 setup.msi. Takes just a couple of minutes to load the installer before we see anything on the screen. Okay, so again we get the Orion setup screen, which is welcome to Orion setup wizard. Press next. Recommend install it in the default folder, which in this case is C, and we press the install. User account control is asking us if we're going to allow this installation. We say yes. So this should install Eclipse and the compilers for the Spark processor. Okay, so that's the installation complete, and it will have created a couple of new shortcuts on the desktop, one to Cygwin, one to MSys, but the one we need here is the Orion Eclipse. So let's double click on that. Okay, so it asks us to select a workspace. So the workspace is where you're going to store all your different C, C++ projects. Okay, I already have a workplace, so I'm going to browse and that. It's in my documents folder called Workspace. Okay, so it has now opened up the Orion workspace. I have one project here, project called test. Let's create a new project just to show you how to create a project from scratch. So if we go to File, New, and it's a managed make C project that we'll go for. Project name is, call it demo. Okay, project type we need to select, and there's a drop down menu here. So the simplest type is the last type here. It's a Spark Help GCC toolchain with a link without an operating system. So we'll select that. Okay, no additional project settings. So now let's close that. So now we have a new project. So in this project, the usual thing would be to create a new source folder to store all your sources. So we'll create a new source folder. We're going to call the folder name SRC. And in the SRC folder, we're going to create a new source file. Okay, source file, let's call it main.c. Okay, so we're now, well, we can go in this window here and edit whatever we want in the main.c file. Okay, well, rather than edit it in, I'm going to copy it from another source file that I have, which is literally a hello world. So let's select the text there, copy it, go to main.c, paste it in, Control S to save it, and then let's build the new demo project here. So if we right click on demo, there's an option to build the project. Okay, we can see down here in the console window, just make it that a bit bigger. So it's removed any old files, it's built the file main.c, it's linked it into a file called demo.exe. So we have now compiled and linked Spark C application. So that's the end of this session. Okay, so in this session we're going to start up Daemon and connect to the target, download a program, run it, and just show very briefly some of the features of Daemon. So I'm going to start Daemon from a desktop shortcut. Daemon can take a lot of command line switches, and if you're going to start from a shortcut, then you need to right click on the shortcut, go to properties, and after the Daemon shortcut you specify the switches you're going to use. In this case here we're using the -GUI switch, which will start it up with the graphics user interface enabled, /DDR in it. On the V1 development boards it was necessary to initialize the DDR memory with the DDR in it switch, and then a -U option which redirects all the output, the printfs, which would normally go to UART1. It directs them to the console within Daemon, so that if you put printf debug statements into your program or just output from the program, it will come out on the console of Daemon. Okay, so let's start up Daemon by double clicking on the icon. Okay, first thing it does is Daemon searches for a license, then it initializes the board. Well, okay, so now we're at the main Daemon window, if you like. Just quickly to describe what we have here, this is the console window. The console window displays a welcome message. The startup command switches in use, -GUI, -DDRNet, and -U, which we set up on the desktop shortcut. It tells us about the serial port which has been used to connect to the target. So in this case we've got COM4 at 115,200 baud. Then we get information about the target itself, the device ID, library version, the detected frequency. So these system on chips, or the target, can run at different frequencies, so Daemon normally calculates the frequency to let you know how fast it's running. And after that then we get a list of the IP associated with the system on chip to which you've connected. On this one here we can see, which is the E698PM, we can see that there's 4 Leon 4 Spark processors, bridges, the AHB bridge, cache controller, memory scrubber, unidirectional AHB bridge. So in total we have 38 pieces of IP on this system on chip. Target, there's a target initialize message. The runtime paths for Daemon are displayed. The license key information, It's a hardware key, the one that came with the development kit, the black one. It's the serial number, which can be used for support purposes, or if you need a license extension, you need to give OCE the serial number in the future. It's an expiration type license, and the end date is, for this one, is the 1st of September 2017. So that's the console window. Over here on the right hand side we have a schematic indicating a schematic of the SoC to which you're connected. This window, or any window which has a little plus sign here, can be double clicked on to be opened as a separate window. So now we've opened it as a separate window. We can see all the various pieces of IP connected. If you have multiple monitors, then sometimes people open up windows and move them to other monitors so that they can have multiple windows while they're debugging their application. Okay, so I'm going to close that. So on this diagram here, by clicking on any piece of IP, it will be highlighted up on the top of the screen where each IP has a separate window to allow control of it. So if we, for instance, click on this one here, Mem Scrub, which is the memory scrubber, as soon as we click on it, up here, the memory scrubber is highlighted. The various registers associated with it are displayed. Let's have a look at one here, the status register. Okay, status register is opened in another window. Then the various bit definitions within the status register are displayed and can be either read or set from here. Okay, so in addition then to the, let's go back to the left hand side here. In addition to the console, we've got the internal log, which is also written to disk, and that's just a list of, it's a log generally used for system type problems that OCE might request a copy of the system log. But it lets you see the commands that have been executed, and can be useful, as I say, for debugging. Then there's a TCL window where you can interactively develop TCL scripts and run them. Python window where you can develop Python scripts, edit them in, run them, or indeed to develop daemon batch scripts and execute them. So let's go back to the console window. Okay, in the Orion 2 installation, we set up a small Hello World program and compiled and linked it. If we want to download this program, we can click on the load icon on the screen. This opens up a load command dialog window. We can select the file we want to download. Okay, in our documents folder, go to workspace, which is where I had stored the program that we set up, which is called demo. And if we go into the demo folder, we see that the source and debug folders, the executable is stored in the debug folder called demo.exe. So if we select, double click on that, ready to select it. Okay, so now we can load this program from my PC down onto the target from where we're going to execute it. So I've clicked load, and because we're over quite a slow link, it takes 2 or 3 seconds to load the program. It displays the names of the sections it's loaded. .text section stores the executable instructions, then there's a .data section, and it's It's read in 231 symbols. The entry point for it is it's 40 million in X. This is where the program is going to start executing. Okay, to run this program, we can click on the run icon here, and when we click on it, it tells us that the program has started. It displays the hello world. Program is executing. Its printf, which would normally go to UART1, has been redirected to the console. And then the program, we get a message saying the program has exited normally, and we see we get some additional information, symbol information about where the address that the program is executed, and track numbers, etc. So that's a very brief introduction to running daemon and downloading and executing a program for the first time.